Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. As you can hear that I'm still sick, and if I need extra time in recording the video, I'm sorry in advance. So here is a problem because I can only have the figure fit in this camera. So let me just say the problem set by word. Okay. The problem is that we have a triangle ABC, and we find the circumcenter O, right? And we find the point A prime, B prime, C prime on the side BC, AC, AB respectively, which can have the property that B, A prime, O, C prime are cyclic. C, A prime, O, B prime are cyclic. A, B prime, O, C prime are cyclic. Okay. And based on this, we have the triangle A prime, B prime, C prime. And now if we find the circle that's centered at B prime with a radius of B prime C, which you can see this black circle here, right? Centered at B prime with a radius B prime C, it intersects with a circle that's centered at C prime with a radius C prime B. And these two circles meet on 2 points. One point is A double prime, another point is D here. And we can call this radical axis as LA. Okay, line A. Similarly, you can find line B and line C. And line A, line B, line C form a triangle in the center, which is NLM here. So what we want to do, we want to prove that triangle ABC and triangle NLM share the same orthocenter. Okay, we want to find that the triangle ABC and triangle NLM share the same orthocenter. I think this problem relates to one problem from Iran Olympiad computation. Okay, so you can see figure is quite complex, and if we want to solve this issue, let's just start from the very simple figure first. By the way, this is one point that I want to make when you study about the geometry or whatever the subject. Always find the, you may be given a very difficult problem, but you can start from very, very simple, very, very basic stuff and understand everything in this basic stuff. And then you gradually add extra component or in geometry, the circles, the lines, and find the properties, find the theorem. So based on the additional conditions, right? And understand the current situation fully, and then go to the next step. This is a way that to do a research or to learn a thing by yourself. Okay, let's start. So first thing that we construct the basic figure, which is we have the triangle ABC here, and we find the circumcenter O, and think about how can we construct or how can we find point A prime, B prime, C prime. We just find an arbitrary point A prime on the side BC, and then we can draw the circumcircle of triangle BA prime O, right? Which is the circle BA prime OC prime here. And then based on the triangle CA prime O, we can find the circumcenter of it meets the AC on B prime. Then we know that we find the B prime and C prime. Now let's just simply prove two things. The first thing is that if we do so, the C prime O, B prime A must be cyclic, right? The second thing would be we want to find the relationship between triangle A prime, B prime, C prime, and the triangle ABC. Okay? So for the first thing, if B A prime O C prime is cyclic, that means we can connect here the CO OA prime and OB prime, right? So we know that angle C prime OA prime equals to 180 degree minus angle B, and angle A prime OB prime equals to 180 degree minus angle C. So we know that angle C prime OB prime equals to 360 minus angle C prime OA prime minus angle A prime OB prime, which equals to angle B plus angle C. Right? That tells us that angle C prime OB prime plus angle A equals to 180 degree. So we know that C prime OB prime A are cyclic. Right, that's our first step. We just prove that this is a correct method, and this is very easy to find the points A prime, B prime, C prime. Now we want to find the relationship between the triangle A prime, B prime, C prime, and the triangle ABC. I would say they are similar. Let's prove it. We connect here, right? So it would be easier for us to look at the triangle. So now think about that we want to prove this triangle is similar to this triangle. We just need to find, let's say, for example, what's this angle, right? This angle equals to the angle C prime, A prime, B prime, equals to angle C prime, A prime, O, right? C prime, A prime, O plus O, A prime, B prime. Angle O, A prime, B prime. And what is angle C prime, A, O, C prime, A prime, O? That is angle C prime, B, O, right? So it equals to angle C prime, B, O plus what is angle O, A prime, B prime? That is angle OCB prime. And C prime, the angle C prime BO is angle ABO, right? And angle ABO is 90 degree minus angle C, right? And angle OCB prime is angle angle OCA, which is 90 degree minus angle B, which equals to 180 degree minus angle C minus angle B equals to angle A. So we just prove that angle C prime B prime, angle C prime A prime B prime equals to angle A, which we can use a similar way to say that angle A prime C prime B prime equals to angle C, angle A prime B prime C prime equals to angle B. So we got that triangle A prime B prime C prime is similar to triangle ABC. Why these are helpful to our future conclusion, we don't know. We just understand this figure first, right? Okay, so we have some solid conclusion here. We know that we can how to construct the circles. We can how to find the points of A prime, B prime, C prime, and we just prove that the triangle A prime, B prime, C prime is similar to triangle ABC. next step. Now we want to add the circles in, right? So first we just add one circle, which is a circle centered at B prime with a radius of B prime C. So we just add this circle here, then we can find several new points, right? This circle intersect side BC on point A double prime. It intersects the circle AC prime B prime on a point E, and also it intersects the circle AC prime B prime on another point D. Let's figure out what's new about these points. The first thing that I want to introduce is that actually C prime, A double prime, B prime are cyclic. Why? It's very easy, because we know that B prime A double prime equals to B prime C, which means this angle equals to this angle is angle C. Right, this is angle C. And we know that this angle, we just proved that triangle A prime C prime B prime C prime is similar to triangle ABC, right? So the angle A prime C prime B prime is angle C. So this is angle C, this is angle C. That means A prime, A double prime, B prime, C prime is cyclic. I mean, these 4 points are cyclic, right? Now, a second thing is that we want to prove that C prime, E, A double prime are collinear. These 3 points are collinear. Let's just connect C prime, A double prime, neglect E here, right? Let's see. Let's say this C prime, A double prime meets a circle AC prime, B prime on a new point. Let's call it E prime. So we want to prove that E prime is point E, right? So think about E prime. What's so special on this E prime? The E prime is an intersection point of this circle, and also E prime is on C prime A double prime. Now we connect E prime B prime. Okay, because E prime is on the circle A C prime B prime, that means angle C prime E prime B prime equals to 180 degree minus angle A. So angle C prime E prime B prime equals to 180 degree minus angle A, which means the angle B prime E prime A double prime equals to angle A. Right, this is 180 degree minus angle A, so this must be angle A. And we already know that the angle C prime A double prime B prime equals to angle C prime A prime B prime, which is angle A. So angle C prime A double prime B prime equals to angle C prime A prime B prime equals to angle A. That means the angle C prime A double prime B prime equals to angle B prime E prime A double prime, right? So the angle C prime A double prime B prime, this angle equals to angle B prime E prime A double prime, this angle, which means BE prime equals to BA double prime, right? B prime E prime equals to B prime A double prime, which means that E prime is also on the circle that's centered at B prime with a radius of B prime C, which means that E prime is a point E. So, and we already know that C prime, E prime, A double prime are collinear, so we know that CE, A double prime are collinear, right? We get C prime, E, A double prime are collinear. Will it be useful? We don't know. Now we look at the full figure. Because we just proved that A double prime, A prime, C prime, B prime, they are cyclic, right? Which we can have the conclusion that A prime, A double prime, B double prime, C double prime, they all cyclic, which I draw the circle here, right? It's very straightforward to think. And now let's say, consider D is a cross point of the circle B prime the circle centered at B prime with a radius B prime C, and the circle centered at C prime with a radius C prime B, right? That's a cross point. We got point D. And let's prove that this point D is also on the circle A, C prime, B prime, right? We want to prove actually these three circles are concurrent on the same point. We want to prove that. So let's consider D as an intersection point of this circle and this circle, right? We want to prove that D is also on the we want to prove that D is also on the circle A, C prime, B prime, which means we just need to find the angle C prime, D, B prime, right? C prime, D, B prime. We just need to find this circle. And to do that, just look at how did we get the D. We get the D from the intersection point of this circle and this circle, which means the angle C prime D B prime equals to angle C prime A double prime B prime, right? It's just a 2C, something like this. This is C prime, this is B prime. This point is A double prime. I think I left one part. Sorry. Let me come back to this one. Let's just think about what we already have. We just proved that C prime, A double prime, B prime, this angle, because the C prime, A double prime, B prime, they're cyclic, right? So we just proved that they're cyclic, so we know that angle C prime, A double prime, B prime, this angle is angle A, right? So now let's look at this. This is angle A, this is angle C, which means the angle C prime, A double prime, B is angle B, which means the C prime B equals to C prime A double prime, right? So that means A double prime is not only the intersection point of the circle B prime C to the set BC, it's also on the circle centered at C prime with the radius C prime B, right? Because the C prime B equals to C A double prime. And now let's come back to here. We just proved that C prime A double prime, A double prime is a point on both circle C prime with radius C prime B and circle centered at B prime with radius B prime C, right? So this is A double prime, and this point is D. So we know that the angle C prime D B prime equals to angle C prime A double prime B prime equals to angle A, right? So the angle C prime D B prime equals to angle A equals to angle C prime A B prime. So we know that C prime, B prime, A, D are cyclic, which means that D is a concurrent point of these three circles, okay? And we know that D A double prime is our radical axis, also the line LA. Okay. And before we going further, let's think about another set of collinear here. Consider that we have this circle, right? The circumcircle of the triangle A prime B, the circumcircle of the A prime B prime C prime, which also passing through A double prime B double prime C double prime, right? And think about we have two circles, right? One circle is centered at B prime with a radius B prime C, and another circle centered at C prime with a radius C prime B. Now this circle B prime centered at B prime with a radius B prime C, it intersects the circle A prime B prime C prime on a point E, right? And remember we proved that C prime, E, A double prime are collinear. So it also meets this circle on another point I. And the circle centered with C prime, centered at C prime with a radius C prime B meets this circle C prime, meets a circle C prime A prime B prime on 2 points, right? One is A double prime, and another point is J, right? Sorry, this circle meets a top circle on E, okay? So now let's think about, can we prove that J, B prime, D are collinear and D, I, C prime are collinear? Right? We want to prove that B prime, D, J are collinear. And also D, I, C prime are collinear. You can see they're actually symmetrical, so we prove one and another one is automatically being proved. So let's see what we can do here. CG. Yeah. Let's think about B, D, and B, I, right? We connect BD here, B prime D. We connect B prime D here. And we connect C prime, B prime here. Right. Let's just connect the C prime and D. Let's call that this is I prime. Excuse me. Let's call it I prime. We already know that the angle C prime D B prime is angle A. So this is angle A, right? And we know that hold on, let me think. We want to prove that what is the point I? Point I is actually the point that with a circle centered at B prime with a radius B prime C that intersect with this circle, right? That's the I. Which means that I is on this circle, the circle B prime, and also on the circle A prime, B prime, C prime, right? So if we want to prove that this I prime, see, when we connect the C prime D, meets the circle C prime, centered at C prime with radius, centered at B prime with radius B prime C, that's a point I prime, right? Now we want to prove that this I prime is also on the circle C prime, A prime, B prime, right? So we want to calculate for the angle C prime, I prime, B prime, right? And because the angle C prime, D, B prime is angle A, we know that B prime, I prime equals to B prime, D. So we know that this angle is also angle A, right? Which means that this is angle A, the angle C, A prime, B prime is angle A. That means I prime, C prime, A prime, B prime are cyclic, which means I is also on the circle A prime, B prime, C prime, which means I is on the segment C prime D. It's on the circle centered at B prime with radius BC. It's also on the circle A prime, B prime, C prime, which means that the cross point I and this I prime, they are the same point, and C prime ID are collinear. So similar for the point J. And for this point, let's call it X. We can also prove that X, B prime, A double prime are collinear, which is similar to C, A double prime are collinear. Okay? So that's another set of the property. Now let's look at the property we got so far of the A double prime, B double prime, and C double prime. I would say that A double prime, B double prime, C double prime. These 3 points that is defined by the circle A prime, B prime, C prime, right? And when we find these 3 points, A double prime, B double prime, C double prime, think about the circle B, A double prime, C double prime. So let's say we want to prove that the circle B, A double prime, C double prime, the circle A, B double prime, C double prime, and circle C, A double prime, B double prime, they are concurrent on a point H, and this H is also center of the triangle ABC. We want to do that. How can we do that? The first thing, we want to prove that these 3 circles are concurrent, right? Which is very easy to do. It's similar to what we did previously. If, let's say, H is intersection point of this circle and this circle, then we know that this is 180 degree minus angle B, and this is 180 degree minus angle A, right? So we got this to be 180 degree minus angle C. Then we know that CA prime, H, B double prime are cyclic. And now we want to calculate for the, we want to prove that H is also center of the triangle ABC. One easy way to do is to think about how can we prove it from the angles, because here, if you just draw a line from A to H and we want to prove 90 degrees, that's very, very difficult. But from the orthocenter property, we introduced the one thing that if we can calculate for the angle BHC, right? If angle BHC equals to 180 degree minus angle A, and angle AHC equals to 180 degree minus angle B, and then you know that angle AHB must be equals to 180 degree minus angle C. So then we know that H is also center of the triangle ABC. We introduced this before. Now let's just think about how can we prove that angle BHC equals to 180 degree minus angle A. So angle BHC can be rewritten as angle BHA double prime plus angle A double prime HC, right? So this angle equals to this one. Right, so the angle BHA double prime equals to this one. Let me just make this. The angle BHA double prime equals to angle BC double prime A double prime, which equals to angle C prime C double prime A double prime, right? Equals to this one. And this one equals to angle C prime B double prime A prime. C prime A double B double prime A double prime, right? This one equals to this one. Okay, equals to this one. And then what is angle A double prime HC? The angle A double prime HC equals to angle A double prime B double prime C. Right? This one equals to this one. Now we can see if we connect C prime B double prime. Now we can see the angle BHC. Because it equals to this one plus this one and this one equals to this one equals to this one. And this one equals to this one. So we have this one equals to this one here. And the angle C prime C double prime A double prime equals to angle C prime B double prime A double prime. So equals to this one here. Then we know that the angle BHC equals to angle C prime B double prime C. Right? And then what is this angle? What's this? What's the angle C prime B double prime C? We have to understand what is B double prime. B double prime is, if you look at the circles around it, that's this circle, right? This circle is a circle with a radius C prime A that centered at C prime. So, which means C prime A equals to C prime B double prime. C prime A equals to C prime B double prime, which means that angle C prime A B double prime equals to angle C prime B double prime A equals to angle A. That is saying the rest part of the angle C prime B double prime C is 180 degree minus angle A, which is angle BHC, which means that H is a isocenter of the triangle ABC. Okay. Now let's consider our problem. Our problem is saying that we find the radical axis of these three sets of the circles, and the radical axis meet on point NLM, right? And this is a triangle. We want to prove that the isocenter of the triangle ABC, which we just found it, the H is also the isocenter of the triangle NLM. Now let's think about the triangle NLM first, right? Because you can see NL is a radical axis of circle B prime, centered at B prime with radius B prime C, and the circle centered at C prime with radius C prime B, right? That's a radical axis for these two black circles. And the line LM is a radical axis for these two red circles. And the radical axis NM is for the these two blue circles, right? So we know that this radical axis NL is perpendicular with the C prime B prime, right? That's a center connection line. So a radical axis is perpendicular to the center connection line. So we know this is perpendicular to C prime B prime, and LM is perpendicular to C prime A prime. Similarly, NM is perpendicular to A prime B prime, which means the triangle NLM is similar to triangle ABC. I mean, it's similar to triangle A prime, B prime, C prime, so it's similar to triangle ABC, right? If we care about the order, so we know that this angle is actually equals to this angle. So the triangle NLM is similar to triangle BCA, okay? This angle equals to this angle. Now, if you look at this figure, it tells us more things. Because this angle is angle B, right? This angle equals to this angle. That means A double prime, B, C double prime, N are cyclic. Compared to this figure, that means this point N is on this circle, right? And also, because this is angle C, so this is angle C, that means L, A double prime, C, B double prime are cyclic, right? Which means L is on this circle, right? Because A double prime, B double prime, C, L are cyclic. So L is on the circle A double prime, C, B double prime. Similarly, because this is angle A, this is angle A, so A, C double prime, M, B double prime are cyclic, which means M is on this circle. Okay? Now let's look at the final thing, right? We already proved that triangle NLM is similar to triangle BCA. We also proved that N is on this circle, which you can see I explicitly draw it, and M is on this circle, L is on this circle. Now we want to find that H is also the center of the triangle NLM. Then we prove that triangle ABC and triangle NLM share the same center. How can we do that? That's a question. If you think about how did we find that H is the center of the triangle ABC, we can use a similar thing. We just need to find the angle NHL, right? We need to find that angle NHL. We want to prove that angle NHL equals to angle BHC, which is quite easy to do here, because angle LNH is angle A prime NH, which is angle A prime BH, and the angle NLH because we already proved that H is a concurrent point of these circles, right? So we know that L, A double prime, C, H are cyclic, right? So the angle NLH equals to angle A double prime, CH. Okay, which means that triangle BCH is similar to triangle NLH, which means angle NHL equals to 180 degree minus angle A. Right? We can do these two other two angles, and we know that H is also center of the triangle NLM. Right? Because it equals to 180 degree minus angle A also equals to 180 degree minus angle NML. Right? So based on this property, we know that H is also center of triangle NLM, and also H is a triangle ABC. So these two triangles share the same also center. So this video is also for the geometry treasure, and this problem is a generalization of the 9-point circle. You may be curious why we call it a generalization of the 9-point circle. Because of these points, right? Because of these points, these 6 points. So if you think we shift this point, we shift A double prime all the way to the foot of altitude on segment BC, then the circle C prime, A prime, A double prime, B double prime, B prime, C double prime is a circle of the 9-point circle. Or you can say, let's move the A prime, point A prime to the middle of BC. Then we know that this the circle A prime, B prime, C prime is a 9-point circle. Okay, so that's a generalization of the 9-point circle. I hope you like this video. See you in next one. Thank you.